Hi, this is Swati and in today's video we will see data handling of class 8th. So this is the introduction video where I'll be covering each and every topic of this chapter, and in the next video we will do some most important questions on this chapter, so that once you have watched this video I'm very sure you will be able to do those set of questions. Now let's get started. Firstly, what is data? Let's talk about data. The data is the most important thing in the world. Data is basically a collection of numerical facts regarding a particular type of information. Now, any kind of information that you have is called the data. Now, let's say that in a group of class, in a group of students, you are checking the weight of all the students. So, basically, that is one kind of data, checking the weights of the students. So, any kind of information is known as the data. Now, each numerical fact of this type is known as the observation. Each data is known as the observation. Now, next one, some basic terms of this chapter. Raw data. Raw, the name itself suggests it is raw. It doesn't change. You're not changing anything. Whatever the form of data is, it is in that form only. So, a collection of observation gathered initially is called the raw data. That means you're not touching the data, you're not interchanging anything. Whatever form the data has come to you, that is nothing but the raw data. Now, what is a range? Range is the difference between the highest and lowest values of the observations. Observations are nothing but the data. Now let me take some observations. Let us take the weights of the students: 50, 40, 45, 48, and 53. So I have set of data. This is raw data. I got the weights of the students in this form. The first student weighs 50, the second student weighs 40, the third 45, and so on. So this is known as raw data. Now if I want to find the range of it, range is basically the difference between the highest and the lowest. So it is going to be 53 minus 40, which is 13. Next, statistics. It is the science which deals with the collection of presentation, analysis, and interpretation of numerical data. So the data that you have, the numerical data, if you represent that in, the presentation, if you're analyzing or interpreting something from that data, it is known as the statistics. Next, frequency distribution. First, let me read the definition. Frequency of an observation. Observation is nothing but each numerical fact, each data is known as the observation. The number of times a particular observation occurs in a given data is called its frequency. Now, let me take an example so that you will understand in a better way. Now again, let us take the same example. There's a group of students in a class for which we are checking the weights, the mass of the students, right? So the weight is as follows: 43, 34, 39, 43, 45, 39, 39, 39, and 43, 34. Okay, we have, and let's take 39. We have the weights of the student. These are in kgs. These are the weights of the students in the class. Now frequency is but nothing but the number of times a particular observation occurs. Observation again is nothing but the data. 43 is one observation, 34 is another observation. So each data is an observation. Now, that particular observation, how many times it has occurred. Now, for example, I can see 43, 43, 43. There are three students who weighs 43. So, the frequency of 43 is 3. The number of times a particular observation occurs. Now similarly 39, 39, 39, 39, 39. So there are 5 students weighing the same weight, 39. So if I ask the frequency of 39, it is 5, because The number of times a particular observation occurs is the frequency. Next is, now these are some interpretation of data statistics. Constructing and interpreting bar graphs. So I'm sure bar graphs you must have learnt in your grade 7th and 6th. So it's nothing new. It's the same thing. A bar graph is a pictorial representation of a numerical data in the form of rectangles. So numerical data, when you have numerical data, it's sometimes boring. So if you represent that in picture form, then it seems interesting. And that picture form is nothing but the bar graph. How do we represent the bar graph? On the axis, you have your x-axis and the y-axis, and you represent here in the rectangular bars equal with varying heights. Now these rectangles are drawn either vertically or horizontally. You can draw vertically or horizontal, keeping equal space between them. In the bar graph, you will have the spacing between each rectangle, equal spacing. The height of the rectangle depends upon the numerical value. Now, how do we construct? Here is one example for you to better understand. Always, to construct a bar graph on the x-axis, we always consider the data. Okay, so in this case, it is the subject. In subject, what do we have? We have English, we have math, we have Hindi, we have social studies and science. Okay, and the y-axis always refers to the frequency, the numerical data. Now marks, you can see 54, 82, 63, 38, 70, right? So I think I can take 10, 10. Your difference should be same throughout. I can start with 10, 10, 20, 30, 40, 50, 60 and 70. Alright, now let us construct the bar graph. English marks obtained is 54. So it is, somewhere in the mid. So this is English. Alright, now maths is 82. So here let us just extend this. Okay, I'll just extend this y-axis and we'll have another, number we can have till 80. 80 and yeah. So maths is 82, so it will be somewhere higher than 80. Yes, this is maths. Next is Hindi. Hindi is 63. So it is above 60. All right. Next is social studies 38. So see, I should have the equal spacing. The spacing between each bar should be equal and also the width of each bar should be same. I hope this is clear. Similarly, science and social studies, you're going to mark it. This is how you convert a numerical data to a pictorial representation. Next up is pie charts. These are all representation of the data. In a pie chart, the various observations or components are represented by the sectors of a circle, and the whole circle represents the sum of all the values of the component. Now, or we have understood that yes, when we draw a pie chart, we need circle, right? To get a circle and to construct angles in circle, you need to know the angles. How do we find the angle? Central angle for any component. The value of the component divided by sum of all the values. The particular value divided by total values into 360. Why into 360? Because it's a circle, the complete angle is 360. Now let's see one example for you to understand. Now here let me draw a circle. Okay, this is my circle and this is my center. Alright, now how do we find the data first? First is food. Now, what is the formula? The value of food is how much? 6300 divided by total values, total components. So when I add them all, 6300 plus 4200 plus 39 plus 4800 plus 2400. The total value comes out to be 21600. So the value of the component divided by total into 360 degrees. So these two zeros cut, and I think, can we cancel here? Yes, we can cancel. So when we solve this, we get the angle as 105 degrees. Now how do we construct? Whenever we draw a circle, we will always have the radius. 105 will be more than 90. This is 105. This is food, right? You can write food over here. Instead of angle, you can just write food. Anything is fine. Now similarly, the next one, rent. Rent is again how much? The value, which is 4200, by the total value into 360 degrees. Upon solving, we get as 70 degrees. Now how do we construct 70? Now you will have the protractor on this line and look for 70 degrees. Now this is your radius kind of. 70 will be somewhere here, so this is 70 degrees, right? Similarly, education is 3900 by 21600 into 360 degrees. Zeros cut, and upon solving we get it as 65. Same procedure. Now here you're going to put the protractor and you're going to mark 65 degrees. Next up is savings. Savings, again the value, which is 4800, by the total value into 360 degrees. Upon solving we get 80 degrees. So this is 80. Instead of these angle, you will write food, rent, education, savings and all that. And last you're going to get 40 degrees. So this should be 40. So when I add all these angles, I will definitely get 360 degrees. Only then the solution is right. I hope this is clear how to find the pie charts. Next up is probability. The next set of chapter in this next set of topic in this chapter. Probability is very important. Now let us see what is probability. In everyday life, we come across statements such as most probably, chances, doubt. All these are not sure words, right? When you're not sure, we use these words. Most probably it will rain today. Chances are high that the prices of petrol will go up. We are not sure if the prices will go up or down, but chances are high. I doubt that he will win the race. So all these show that the probability of occurrence of an event. How much chances are there for any event to occur. That is nothing but probability. Now here you have some terms. Let us understand those terms. Experiment. An operation which can produce some well-defined outcomes is called an experiment. Each outcome is called an event. Now suppose each outcome. Now let me take a coin. When I toss a coin, I get two outcomes, right? I get head or tail. These are the two outcomes when we toss a coin. Yes. So each outcome is known as an event. And this operation that we are doing, this operation that we are producing, is known as an experiment. Next, random experiment. An experiment in which all the possible outcomes are known and the exact outcome cannot be predicted in advance is known as a random experiment. See, whenever you perform any experiment, I'm sure you know what are the outcomes. Like suppose when you toss a coin, you have two outcomes, heads or tails. When you roll a dice, you have six outcomes, 1, 2, 3, 4, 5, 6. So we already know what are the possible outcomes. But we do not know exactly what outcome will appear, right? When we toss a coin, I cannot surely say that yes, the heads will come up. No, we cannot say that. So that is known as a random experiment. that we know all the possible outcomes, but we cannot predict what outcome is going to appear in advance, right? So if I read this, you will understand. When we throw a coin, we know that all possible outcomes are heads and tails. But if we throw a coin at random, we cannot predict in advance whether the upper face will show heads or tails. So the prediction cannot be done. All the total outcomes are aware of, but what will appear, we are not aware of. I hope this is clear. Next up is, here are some experiments and their outcomes. As we have just discussed, when we toss a coin, you have heads or tails. When we toss two coins, you have heads, tails, heads, or tail. And when we throw a die, we have 1, 2, 3, 4, 5, 6, right? These are the outcomes, common outcomes that for these experiments. Now, you have one more kind of question, cards. This is very important. Most of the students are well versed with these cards, but most of them do not know. So let me just explain you. Drawing a card from a well shuffled deck of 52 cards. So in a card you have, in a deck of cards you have 52 cards. A deck of playing cards has in all 52 cards. It has 13 cards, each of 4 suits. So you have 4 suits: spades, clubs, hearts, and diamonds. Each suit is 13. So 13, 13, 13, 13 mix up to be 52. So you have 2 black cards, spades and clubs, and you have 2 red cards, hearts and diamonds. So black, if I talk about black, you have 13 plus 13, 26 black cards. Similarly, reds are also 13 plus 13, 26 red cards. So 26 red, 26 black, together 52. Now what are these 13 cards? See, each suit has kings, queens, and jacks. So each suit. Now suppose I'm telling each suit has 13 cards, right? What are these 13 cards? It is king, that is K. It is queen, Q, jack, J. Now these are all known as face cards. Face cards because they have faces on the cards, right? So that is why it is face cards. So in total, if I talk about face cards, how many face cards do we have? In each suit we have 3 face cards, we can see. So 3 plus 3 plus 3 plus 3. So all together there are 12 face cards. You should be knowing there are 12 face cards. But if I specifically ask how many black faced cards, half. It is going to be 6 black faced cards. Similarly, 6 red faced cards. Now what are the remaining? I'll just write it over here. It starts with A's, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you have jack, king, queen. So all together you have 13 cards in each suit, right? When we do questions, you will understand more clearly about these cards. Next is an event. The collection of some or all possible outcomes is called an event. Now we just saw when we throw a coin, you have H is the event of getting a head. In throwing two coins simultaneously, HH is the event of getting two heads. When we roll a dice, if we want a even number, how many even numbers do we have? 2, 4, 6. So this is an event. So you always know all the collection of possible outcomes. That is known as the event. Next is, what is probability? The most important. We have learned probability. We have seen what kind of events we have in the probability: coins, dice, and cards. Now, what is a probability? Let E be an event. We just saw E is basically the possible outcomes of any experiment. So how do we find the occurrence of the event? Is the number of favorable outcomes by the total number of outcomes. For example, if I throw a dice, my total outcome is what? 1, 2, 3, 4, 5, 6. These are my total outcomes when I throw a die. Now I want to find the probability of having an odd number appearing. So how many odd numbers are there? So that is nothing but number of favorable outcomes. How many odd numbers are there? 1, 3 and 5. These are the three odd numbers. So my probability of this event is going to be the favorable outcomes, that is 1 2 3 3 divided by total outcomes. There are 6 outcomes. So this is my probability. So probability is the favorable outcome. That means what is the question asking for, divided by total outcomes. I hope this is clear. So this was all about the data handling. I have covered each and every topic of this chapter. So stay tuned for my next video, as I'll be sharing all the important questions that generally is asked. So once you have watched this video, only then watch the next video so that you will be able to do the questions on your own. Thank you. And if you haven't subscribed the channel, do subscribe it. Thank you.